All right, let's look at yet another example on how to solve problems on indices. Let's look at this example here in front of us. How do we possibly simplify this? How do we possibly simplify or perhaps evaluate this problem here? My task now is that I'll try to factorize 3n here. Of course, I'm having 3 to power n common. As you can see that they are more common in everything here. So the task now is that before I proceed, let me explain something, please. If I have 3 raised to power n minus 1, I can break this down as saying 3 raised to power n times 3 raised to power minus 1. True or false? True. Look up, please. I can use this 2 to get back to this. How? Of course, look up. This is a like basis. We said when like basis are multiplying, we said simply what? Add their power. That becomes 2 to power n plus into minus 1. We say add their powers. So that becomes 3 to power n plus minus is what? Minus 1. So of course, observe that with this one here, I go back to this. So I can express this one in terms of this and still be correct, please. That's the concept, please. So at this point now, let's see how we can possibly simplify this. This is minus 1. Is this one still minus 1? All right, they are both minus, please. So they are both minus, please. So let's see what we can do here. Very first thing here is that solution. My very first task here is I'll have 3 to power n minus, we said express one in terms of that. So that becomes 3 to power n times what? 3 to power minus 1. But if I combine these two, I'll get back to this as I proved to you earlier there. So all over this 3 to the power 3, right, times 3 to the power n, I'm done with this, minus, of course, 27 can be expressed in terms of 3 to the power 3. So I know that 27 is still equal to 3 to the power 3. That's 27. So replace the value there. I'll have 3 to the power 3, right, times what? Express this one in terms of that. That becomes 3 to the power n times 3 to the power what? Minus 1. So I have this. Of course, 3n is here, 3n is here, 3n is here, 3n is here. So I'll factorize it out. So for my numerator, I have 3n common, 3n into, this becomes 1 minus what? 3 to the power minus 1. Of course, observe. 3n times 1 will give 3n, minus remain minus, 3n times 3 to the power minus 1 will give 3n times 3 to the power minus 1. Of course, the same thing, please. So all over 3n is common here, 3n is common, bring them out, that becomes 3n into, I'll have 3 to the power 3 minus 3 to the power 3 times what? 3 to the power minus 1. So this is what I'm left with, please. So if I combine this with this, I'll have this. If I combine this one with this 3, I'll have this 3 expression here. So that is the same thing, please. Now I will cancel out this, we cancel out this. So I'm left with what? 1 minus 3 to the power minus 1 all over 3 to the power 3. Of course, this man is what? 27 minus what? 27 times what? 1 over 3. Of course, negative index law. This minus becomes 1 over 3 to the power minus 1. That's 3. I have this. Of course, 3 here 1, 3 here is 9, right? So all I have here, this gives 1 minus 1 over 3, right? This one 1 over 3, all over what there? 27 minus 9 times 1 is what? Of course 9. So I'm having 9 left here, right? So the task now is that 1 minus 1 over 3 becomes 2 over 3, right? So 2 over 3. So all over 27 minus 9 is of course 18, right? I have 18 here. Now let's simplify this more better. This becomes your concept here. So this becomes 2 over 3, 2 over 3, right? Divided by 18 over invisible 1. To change the division times, I will apply reciprocal concept. That becomes 2 over 3 times what? 1 over 18. 2 here 1, 2 here 8, right? So if I multiply the 2, that becomes 1 times 1 is 1 over 2 times 8 is what? 27. So I have this as being my answer, right? As you can see, so 24. Sorry, 24, please. So I have 24. So that becomes how to solve this particular problem using the idea of indices. That's your answer. So if you found this class helpful, know where to like the video, subscribe to my channel. So see you in the next class. So next class, we'll try to look at the concept of indicial equation, or we call it exponential equation, in the next class. So see you in the next class.